Alright, hello everybody, welcome to the Chapter 5 study video. We'll be taking a test tomorrow, and it's going to cover all of these wonderful topics. We can see we have a lot to go through, so I'll probably be explaining very quickly and going through the slides quickly. What I would suggest for you guys is when I start a page, pause the video, write down the problem, try and solve it for yourself first, and then see if my explanation matches yours and you get the right answer. So, for this video, we'll be looking at solving for one variable, simplifying exponents, looking at the domain and range, systems of equations, determining whether a sequence is arithmetic, geometric, or neither, and then write the explicit and recursive equations. I believe I do not do an example of domain and range. You should have lots of examples of those from your book. We've also done some in class in your warm-up, so check back to old notes for those. And we will begin. So first we're going to be interested in solving for x. With problems like this, you're going to want to first distribute, combine like terms. So there'll be some type of math we'll have to do up front. And from there, we'll simplify and condense it down. So we'll get 10x minus 20 plus 3x minus 3 is equal to 3x minus 10. Be careful with this one. Make sure that the number you're distributing, we have a positive 3. So I'm taking and distributing a positive 3 to a positive x and to negative 1. So look for that sign that's out front. Again, here we have another positive 10. So we have x on both sides of the equations, but we also got a lot of simplifying that could help us out. So I can see that there's one spot where I've forgotten an x. There we go. So I'm interested in combining like terms. So I've got positive 10x, positive 3x. So I've got a positive 13x. And then minus 20 and minus 3, which is a negative 23, will be equal to 3x minus 10. From there, I'm going to want to get my x's all to one side. To do that, I'm going to take and subtract 3x from both sides. If you wanted to, though, you could have taken and subtracted 13x. We'll have a different process, but in the end, we should get the same exact answer. So we've got 10x minus 23 is equal to negative 10. Don't forget that negative sign. Lots of people will forget it and just have it go away, but it's still there. We have a negative 10. And I'm going to add my 23 to both sides.
Alex Levy, please report to the front. Alex Levy to the front office.
We'll get 10x is equal to 13. Divide both sides by 10, and x is equal to 1.3. Nothing too tricky about that. Should be starting to feel like something we can do really well, something we can do very fast. So hopefully that one was a good review for you. Next, we want to simplify with exponents. So negative signs are huge, and not so much negatives in front of numbers. Those don't really do too much for us, other than something we have to make sure we're keeping account of. It's those negative exponents that we want to be really cautious of. So in the first one, we have a negative. We're raising everything to a negative 2. And remember, everything, including that 4. So that's 4 to the negative 2, a to the negative 4, and b to the negative 2. Remember that what a negative exponent does is it takes it, if it's in the bottom, becomes the top, and if it's in the top, becomes the bottom. So we're flipping it. Right now we have this all over 1, and we want to, because everything, all of ours are being raised to negative exponents, this then becomes 1 over. 4 squared is 4 times 4. Which will give me 16, my brain stopped, a to the 4th, and b squared. A step that you might have seen in between it is maybe you rewrote it first as 1 over 4 squared, a to the 4th, b squared. And then we do need to take and simplify this down, which is why I had a 16 earlier. 1 over 16, a to the 4th, b squared. And then the other one, we're taking this 2 and we're distributing it to everything.
Excuse this interruption. Jeannie Prestosa, please call extension 6455. Jeannie Prestosa, please call extension 6455. Thanks very much.
With this one, we want to make sure that the thing that we're squaring is negative 4. And so when you put it into your calculator, let me see. I do not have mine pulled up on the screen, so it might take a minute to pull up, but it is worthwhile to see. When we take and we square negatives, we have to be very careful about the way we're putting them into our calculators. Hopefully you're realizing that what we have right there is negative 4 times negative 4, which will give us a positive 16. but when you put it into your calculator, you might be getting a different answer. So let's kind of look at why that is. So when I pull up my calculator, we want to make sure that we're entering it in a very specific way. So on my screen, if I just enter in -4 squared, I'm going to get a -16. But how come when we take and square -4, we get +16? So what's happening is that we want to make sure that if we're putting it into our calculators, we're including those parentheses. Because when we put it inside parentheses, we're going to get that +16. How your calculator reads the first entry is it really sees it as -1 times 4 squared. And if we're following our order of operations, the first thing we do is 4 times 4, and then which will give us 16, and then 16 times -1. So we can see that we get different answers based on the way we put it into our calculators. For that reason, whenever you're taking that quantity and squaring it, make sure you include those parentheses if they belong there. So this is -4 squared. This is the proper way to enter it into your calculator to get the correct answer. All right, bringing it back. So we know we've got a +16 and then a squared, b squared. Moving on. We're going to be looking at solving the system of equations. And so with this one, it's not as easy to immediately solve for one variable and use substitution. And it's not even a matter of adding the two together or subtracting. What we're going to have to do is we're going to have to multiply by a constant and then rewrite it. So when I look at this problem, the one I'm going to want to change is this 2. I know that there's an easy way to make that -4. I'm going to take and multiply everything by -2. And remember, I'm multiplying everything by -2, and then I always rewrite it off to the side. So my top equation then becomes -4x minus 6y is equal to -30. Oh, and then the one underneath didn't change, so I'm just going to rewrite it. So then we can see that we have a -4 and a +4x. Those will cancel out, and we'll be left with -4y is equal to 20. When we divide both sides by -4, y is then equal to -5. And then we've got part of it, but we don't have everything. We're also going to need to take and solve for x. So you can pick any equation you want to put it back into. I'm going to choose the first one. So 4 times x plus 2 times -5 will be equal to 50. I know that 4x plus -10 is equal to 50, so I'm going to take and add 10 to both sides. And I've got 4x is equal to 60. Take and divide both sides by 4. And x will be equal to 60 over 4, which should be a fairly large number. That's not one my brain is allowing me to do right away. So I'm going to put in my calculator. 60 divided by 4 is going to be 15. Look at that, nice whole number. X is equal to 15. So now we have our 2 points, and that point of intersection would be 15, comma, -5. You will see a problem very similar to this, so being able to feel comfortable solving it by multiplying by a constant will be really helpful to you. Next, now the newer stuff, the stuff we've really been talking about in Chapter 5, dealing with sequences, our arithmetic, geometric, and neither. So we want to make sure that we can determine what makes something arithmetic, what makes something geometric, really being able to explain our answer. So when we look at this first one, the sequence 5, 25, 125, 625, hopefully we can see that adding isn't going to be very helpful to us because it's growing so fast. Remember, that's something that was very characteristic of something being exponential, that really quick growth. We can see that we're taking and we're multiplying by 5 each time. And so we know we're dealing with a geometric sequence because we are multiplying by a constant. So, why? Because you multiply by a constant term of 5. So we were able to say what it was and explain why. And then we want to write the explicit equation. So remember, our explicit equation, we're going to be solving for t of n. That's just any term. So with this equation, we'll be able to predict whatever term we want. And we know that our constant rate of change is that 5. So when you think about the slope, a slope is your constant rate of change. So that's what's being multiplied by your variable, by our n. And then we want to find our 0 term. We know that before we would have to multiply by 5. So in order to go backwards, we'll just take and divide by 5, which will leave us with 1. Oh my goodness. So I made a huge mistake. Hopefully you guys caught that mistake. If you notice, the type of explicit equation I am writing is for an arithmetic sequence. But we clearly stated that we have a geometric. So let's fix that up. It's still going to be t of n, but the thing we're multiplying over and over and over again is still that 5. But instead of saying 5n, it's 5 to the n, because we're doing repeated multiplication. And then we're still doing multiplication, and we need it times our 0 term, which we used the correct process in order to find that. So our explicit equation should read 5 to the n times 1. And why that works is if we're looking for our third term, I know the third term in the sequence is 125, and so if I take and plug in t of 3, I'm doing 5 times 3 times 1, or 5 to the third times 1, and 5 to the third is 125. So a good way to check your equation to see that it works is to take something and plug it in and see if you get it. When we do our recursive, remember our recursive has 2 parts. First, we're going to want that first term, which we know is 5. Your first term will always be the first number in the sequence. And then your ability to predict the next term depends on the number that came before it, and then that thing we do every time. We keep multiplying by 5. Another way, you'll see that the questions are exactly the same, but the form it's in is a little bit different. Instead of having a list of numbers, you will see a table. So we'll be able to look at the table and determine whether the sequence is arithmetic, geometric, or neither, and explain. When we look at this one, we can see that we are moving up, or sorry, in this case, moving down. Our sequence keeps decreasing by 4 every time. So we know that we're dealing with something arithmetic because we are decreasing at a constant rate of -4, or adding -4 each time. So now we have something that is arithmetic. So we can have something that when it graphs, it'll look more like a line. We're constantly going down at a rate of -4 times n, and then we're going to need to find out what our 0 term would be. For that, we would just add 4. So we know that our 0 term is 20. Let's check to see that this equation works. I want to find the 4th term. So I should be able to plug in 4. T of 4 will be equal to -4 times 4 plus 20. What that gives me is -16 plus 20, which is really 20 minus 16, which just leaves us with 4, and we can see that it checks out. Lastly, we'll want the recursive, which again, we need to know the first term, which is 16, and then a rule which will help us figure out the next term in the sequence. Well, we're going to have to take the one that comes before it, or t of n, and then subtract 4. Moving on. It says, given the explicit formula, t of n equals 5n plus 10, write the recursive formula. So the first thing they're going to ask you to do is to find the first 5 terms and go from there. All right. So this one, we're going to fill in that table by plugging in our values. So the first thing we're going to do is when it says that n is equal to 1, we can take and plug that in. So t of 1 is going to be equal to 5 times 1 plus 10, which we know is just 5 plus 10, or 15. So the first number we fill in is a 15. Next, we'll take and do the same thing, filling in for 2. So we're t of 2 will be equal to 5 times 2 plus 10, which is just 10 plus 10, which we know to be 20. Hopefully, once we get that first number down, you can start to see the pattern that's emerging, that we're going up by 5 every time. And we can see that also represented in the explicit equation, because it is our slope. That number we are increasing at a constant rate. So one last time, we'll plug it in. T of 3 will be equal to 5 times 3 plus 10, which is going to be 15 plus 10, which is equal to 25. So 25, the next one will be 30, and then 35. And if you're not sure where I'm getting these numbers in, keep plugging it into your equation. So then it asks us to write the recursive formula. We already have it nicely done with our list. We know that our t of 1 is equal to 15. And then here's that part where we have to kind of use our brains. How are we going up each time? Being able to spot that out and seeing that t of n plus 1, you have to take the term that comes before it, your t of n, and add 5. All right, I believe we have one slide left that kind of puts it all together. So again, being able to look at something and decide what type of sequence it is, and then putting together those equations that go with it are going to be huge tomorrow. All right, last one. It says given the sequence 1, 3, 5, 7, we want to write the explicit formula, the recursive formula, and then graph the sequence. Now, I hope my graph isn't too bad. My board does need to probably get recalibrated, so if when I graph it, it's not perfect, I apologize. All right, so we have 1, 3, 5, 7. We can see that we are going up by 2 each time, going up at a constant rate by adding 2. So with that, when it asks us to write our explicit formula, we know we're dealing with something that's arithmetic. So we know that t of n will be equal to 2n plus whatever our 0 term would be. We don't know what it is because it's not in the sequence, but we can figure it out. We take our first term, and then we work backwards by subtracting 2. So 1 minus 2 will be negative 1. So 2n plus negative 1. We can also write our recursive formula. So for that, we're going to need to know what the first term is. That was given to us as 1. And then how we're getting to the next one every time. Well, you have to take the term that comes before it and add 2. Again, when we're looking at the recursive formula, it should be pretty clear, even just looking at the rule, that we're doing something that would be arithmetic. By adding 2 every time, we're showing that that's the thing that we're constantly going up by. So a good way to check yourself is it should include how you know it's arithmetic. And then lastly, they want us to graph it. So hopefully we can see that we just need, we're relating the term it is, so our n value to our t of n value. This is the first term, the second, the third, and the fourth. So we want to plot those points. We want to plot 1, 1. Then we want to plot 2, 3. Then we'll plot 3, 5. Ooh, that's really off. And finally 4, 7. It should be up here. And we're making sure that we know that we're talking about a sequence, which means it's going to be discrete. What discrete means? No lines. So if you're graphing a sequence, do not connect your points. If you can do all the things in this video,